13, plot these ordered pairs. As you plot the points, label them and connect each new point to the previous point by drawing a line. We plot all ordered pairs by starting at the origin. I'm going to label my x and y axes. A is 1, 0. Remember, the x comes before y in your ordered pair, just like x comes before y in the alphabet. You start at the origin, 0, 0, and if x is positive 1, I go 1 to the right. Y is 0, so I don't need to go up or down at all. So point A is right. Point A is right there. B is, and I'm going to label the location as I plot these. This one is in between two quadrants. It's on an axis. It's on the x-axis. B is at 0, -4, so I start at the origin. My x-coordinate is 0, so I don't need to go right or left at all. But my y-coordinate is -4, so I need to go down 4. B is right here, and I'll connect it to the previous point with a straight line segment. And B is again between two quadrants. It's on an axis. It's on the y-axis. C is -2, -4, so I start at the origin. X is -2, so I go 2 to the left, and then from there y is -4, so I go down 4. That's point C. Connect it to point B, and then I need to remember the way to number the quadrants. You make a C. Having this writing tablet, sometimes it gets out of control, but your C, capital C, starts in the first quadrant. Then as you're making it, the next quadrant you pass through is quadrant 2, and then you pass through quadrant 3, and then your C ends in quadrant 4. So that's how you can remember to number the quadrants. So C is in the first, second, third quadrant, quadrant 3. D is at -3, 0, so I start at the origin and I go 3 to the left for -3x. Y is 0, so I don't go up or down at all. And so that point is also on the x-axis. That's point D. I'll connect it to C. I'll connect it to A, and then I can name the polygon. It's a trapezoid. If you happen to notice that the two opposite sides that are not the bases, if you happen to notice that they're congruent, you could also call it an isosceles trapezoid. You don't need to be that specific, but if you do notice that, that is true. These two sides are congruent, so it's an isosceles trapezoid. The area of a trapezoid is 1/2 multiplied by the sum of the bases, multiplied by the height, which is the perpendicular distance between the bases. The bases are the parallel sides, so BC and AD. BC is 2, AD is 4, and the distance between the bases, the perpendicular distance between the bases, is also 4. So I have A equals half of 2 plus 4 multiplied by the height, which is 4. Or half of 6 multiplied by 4. Half of 6 is 3, and 3/4 is 12, so 12 units squared would be the area of the trapezoid. Problem 14. A stray dog ate 12 of your cupcakes. That was 3/10 of all of your cupcakes. How many cupcakes did you start with? We need to write and solve an algebraic equation. The key to doing that is recognizing what the variable is. We want to know how many cupcakes we started with, so I'll use C for the number of cupcakes we started with. And then this written expression can be turned into an algebraic expression. 3/10 here's actually the key. That was, so that represents the number of cupcakes you started with. C was or equals 3. I messed up. Let me take a step back. Sorry about that. I need to really read more carefully. A stray dog ate 12 of your cupcakes. That was, so 12 was, 12, the amount the dog ate, was or equals 3/10 of your cupcakes, which we're saying is C. So 12 equals 3/10 of C. And then you just have to remember that of, in this context, an amount means multiply. So 12 equals 3/10 multiplied by C. That's the algebraic equation. And then to solve it, we don't want to know what 3/10 multiplied by c is. We want to know what 1 multiplied by c is. Because if I can find 1c, I know c, because 1c is c. That's the multiplicative identity. But in order to make 3/10 c into 1c, I need to multiply 3/10 by its reciprocal. So 10/3 multiplied by 3/10 c. If I multiply the left side of my equation by 10/3, I have to multiply the right side of my equation by 10/3. 12 multiplied by 10/3. I have a common factor of 3 here. 3 divided by 3 is 1. 12 divided by 3 is 4. And 4 times 10 is 40. So 40 over 1, which is just 40, equals, all these cancel. This is why we multiplied by the reciprocal. 40 equals 1c. So c equals 40 cupcakes. If we check it, 12 should equal 3/10 c, so 12 should equal 3/10 multiplied by 40, and 10 and 40 have a common factor of 10, so here we get 3 times 4 is 12, so 12 equals 12, so that checks. Here we have another algebraic equation. We're going to try to identify the variable value and then substitute it back in to check. 3/7 h equals 6. I can get rid of 3/7 by multiplying by its reciprocal, 7/3. But then I need to use property of quality, multiply the other side by 7/3. 6 and 3 have a common factor of 3. 3 divided by 3 is 1. 6 divided by 3 is 2. These just cancel to give us 1h. So we get 1h equals 14 over 1, or h equals 14. We can substitute it back in to check. 3/7 h equals 6. So 3/7 multiplied by 14 should equal 6. And 1/7 of 14 is 2, and 3/2 is 6. 6 over 1 equals 6. That checks. Lastly, problem 16. This is a pretty challenging problem. You have to recognize something to be able to solve this. If 8 to the n multiplied by 4 to the second power equals 2 to the 10th power, what is the value of n? And this seems like one of these problems where we are going to use laws of exponents to solve for the variable, but we don't have the same base. We don't even have the same base here, let alone here. You need to recognize, first of all, that 8 is a power of 2. 8 is 2 to the third power. So if you substitute 8 for 2 to the third power, I can rewrite this as 2 to the third power to the nth power times 4 is also a power of 2. It's 2 squared. So times 2 squared to the second power equals 2 to the 10th power. Now we can use our laws of exponents. We know a power of a power would be, you'd multiply these exponents. So 2 to the 3n times 2 to the, again, 2 times 2 here, so 4. And then if we're multiplying powers with the same base, we can add the exponents. So I can write this as 2 to the 3n plus 4 equals 2 to the 10. So that must mean 3n plus 4 equals 10. Now we have a two-step algebraic equation to solve. So we subtract 4 from both sides, property of equality. That gets rid of the variable term, and we get 3n is equal to 6. Then we divide both sides by 3. Property of equality again, so n equals 6 divided by 3 is 2. So n equals 2. I want to check it, so I'm going to go back to my original equation. 8n plus 4 squared equals 2 to the 10th power. 8 to the second power, if n is 2, plus 4 to the second power should equal 2 to the 10th power. This is 64 plus 16. Hesitating because that doesn't seem right to me. 80 is not a power of 2. What did I do wrong? 8 to the second power is 64. Oh, it's not, you may have seen this long before I did. This is not 8n plus 4 squared, it's 8n times 4 squared. So it's not 64 plus 16, it's 64 times 16, which would be 36, 38. $1024. So 2 to the 10th should equal 1024. I know 2 to the 5th is 32. So 2 to the 10th is 32 times 32. 32 times 32. $1024. Okay, so that checks out. So n equals 2. And that concludes the review. Thanks for watching the videos and studying for your test. I know you're going to do great. I appreciate your effort, and I'll see you tomorrow.